Alright, so looks like we're live. Hello, hello. Hope all is well. Welcome back. And we're going to continue this problem. Last couple of streams, videos, I was looking at this problem, kind of poking around at it, thinking about it, mulling it over. And I was trying to even program a perfect square routine that would use binary search to determine whether or not an integer was a perfect square. And I was tinkering a little bit, you know, being Clojure and being kind of new to it. I thought maybe, well, I would learn, I guess, how it can be done. Maybe if it could be done in a functional way. I don't know. I'm learning more about Clojure, I suppose. And yeah, so I think I don't actually need this routine after all. But we'll try to solve this problem. So I'll describe what the problem is again, and then I'll describe what I think the solution is going to be. So English text needs to be encrypted using the following encryption scheme. First, the spaces are removed from the text. Let L be the length of this text. Then characters are written into a grid whose rows and columns have the following constraints. The floor of the square root of L, which is the length of the text after you remove the spaces, is less than or equal to the number of rows, which is less than or equal to the number of columns, which is less than or equal to the roof of the square root of L, where this is the floor function, the ceiling function, or the ceiling rather than the roof, the ceiling of the square root of L. For example, if you take this sentence, if man was meant to stay on the ground, God would have given us roots. After removing spaces is 54 characters long, square root of 54 is between 7 and 8, so it is written in the form of a grid with 7 rows and 8 columns. Right, 7 by 7 would be too little, 7 by 8 is enough, so we take 7 by 8. And we've got to ensure that the number of rows times the number of columns is greater than or equal to the length. Right, so that way, when you write out these characters, you fill the grid. Multiple grids satisfy the above conditions. Choose the one with the minimum area. So there's 3 possibilities, which is 7 by 7, or it's going to be the floor of the square root of L squared, or the floor of the square root of L times the ceiling of the square root of L, or the ceiling of the square root of L squared. Those are your 3 options. You got to pick one, the smallest one that satisfies. The smallest one that's greater than or equal to L. And then the encoded message is obtained by displaying the characters in a column. Excuse me. Okay. Let's see, hold on, what's it say? Multiple grids, right. Coded message obtained by displaying the characters in a column, inserting a space, and then displaying the next column and inserting a space, and so on. For example, the encoded message for the above rectangle is 1, 2, 3, 4, 5, 6, plus another 2 at the end. Note the other 2 are missing a character because the last portion of the grid doesn't have those extra 2 characters. You will be given a message to encode and print. Function description: complete the encryption function in the editor below, which should return a single string composed as described. Encryption has the following parameters: s string to encrypt. Input is 1 line of text, the string s. The size of x is less than or equal to 81. S is comprised only of characters in the range of ASCII to Z. Print the character as described. Print the message as described. And as 1 line. So the solution to the algorithm is I kind of hinted at it. Basically, we're first going to check for which pair we should use, right? So we'll compute the floor, call it floor of the square root of L, call it x, and then compare x squared with x times quantity x plus 1, and then the square of x plus 1, and check which one of these is less than or equal, the smallest one that is also greater than or equal to L. That's what we want. Maybe we'll apply a filter to this sequence using we'll use a transducer with the min function. So that would be interesting. We'll get our first taste of using transducers so we can find out which pair we want. Then what's going to happen is we could actually construct this grid, but let's actually ponder how we might do this if we were not to construct the grid. So I think what we would do is we would say we're going to take, for each column, we want to compose the string of that particular column, which would be, oh yeah, we also, I guess the string, we would remove the spaces. That could be another filter on the string. And yeah, I guess I'm curious. I'm wondering if I actually want to build this grid, if it's even necessary to do that. I don't think it is. I think we can do this using modular arithmetic, and not even modular arithmetic. Well, yeah, modular arithmetic, but more so just access the string at its at the indices. Now I'm wondering if Clojure supports that. Clojure get access, random access to strings. Nth. Okay, so it does work for strings. Nice. So we can do the nth for the strings. Cool. And to get the characters that we're interested in, so we can get the columns. We can write a small routine that'll get the column of the string given. So you would give for the routine, you would give the string, you would give the number of rows, columns, that pair, rows, columns, pair, and which would be destructured, I guess. And then you also would have, or well, yeah, rows, columns, pair. And then finally, which column, which index you want, right? And that can get you the string for that column. So you can say column string is like a subroutine that we can use. We use modular arithmetic to get that particular column. And I have a pretty vague idea of like how we can do it. Usually probably a reduction and some modular arithmetic, or just some basic multiplication using this single array, interpreting it as a grid. We also want, for the column when we access, if we can't access that far into the string, then we just return an empty character, no character, I guess, empty string that we concatenate with. Yeah. I don't know if you can concatenate characters. Yeah, you can. String. Yeah, it'll just be the empty string we use. str, I think, is Clojure has one of these. Not string split, but just string. Yeah. It's good. It's good. So that should do it. And then we can we get each of these column strings, and then we do another reduction on all those column strings to on each of those column strings to generate this return string at the end. So this should be relatively straightforward, this bit. So let's try this. So let's first start with row column, and we're going to say there's this L, and we're going to go ahead and say we said it was going to be a reduction with a transducer, where this transducer is a filter, I think. Yeah, we're going to use this notation as well. I like this anonymous function sort of notation. And it's going to be filter on oh no, I did this wrong, sorry. No, this is totally different. Thinking of something else. Completely wrong thought. It's L is the length, so we know what L is. We can say, we'll say let X be, X is going to be the math.floor of the math square root of L, and this is an integer. Right, and what we're going to do is consider there's a sequence that looks like this. It's X, or just X, 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 inc X, X, X plus 1, and finally X, or inc X, twice. Right? There's this sequence. You don't need these. Commas are considered a white space in Clojure. Now, what you're going to do is reduce this using, let's just say vals. Call it vals. We're going to reduce on vals using the min function, which we're actually going to define here. I don't think they have a min function. Do they have a min function in Clojure? They do. Ah, they do. So we are going to use a min function, and we're going to say we can use an anonymous. We'll use an anonymous function. It's going to be kind of interesting. We want to return a pair. We want to return the pair with. Actually, yeah, we want to transduce. In fact, transduce. So there is a reduction that's going to occur here. We'll put that here. Let's do could even define this here, this function. I think you can bind functions. Yeah, I think that's fine. I think we can. I'd like to do that. Yeah, we're going to transduce. So first this will be a filter. And yeah, I did need to use a filter. The filter is going to be an anonymous function. So let's say filter Clojure. So this anonymous function is going to be given two arguments, argument 1, argument 2. We're going to say that if you multiply these two, these are less than L. Right? You multiply these two inputs, this transducer. Is that correct? No, it's going to be, no, actually that's not correct. It's one argument you give the thing, which is the pair of the vector, a pair of integers, and you're going to actually destructure the, can you have anonymous function destructuring? How do you do this? Clojure. Well, alright, I guess we have to use a let. That's fine. That's okay. Awkward as this may be, let xy be the input. So destructure the input, and then x times y is less than L. And that gives us our anonymous function. It's kind of funky, I realize, but this will perform the first transduce we want. Yeah, this will remove all of these values that don't fit, that aren't less than or equal to L. Actually, it could be greater than or equal to L. So how do we use transduce to get the minimum? I've seen it before, but I don't remember exactly how it's done. the problem with the reduction that we're going to do after this is, how does transduce do? Actually, it's kind of uncertain here. Not sure if I can use transduce the way that I want to here. But what I'm looking for is, I want to get the minimum of these objects with a comparator function applied to these objects. That's sort of the what I'm looking for, which is interesting because it's definitely unusual. I think I've got to write my own custom function, which will look like the following. Yeah, this is kind of interesting, but basically you have two arguments, which is the previous and the current, and we'll start with XX, or we do inc x, I think. Start with the maximum, and say if what we're going to do is, goes like this. If, so we destructure both of them. Alright, so I want something, we could do it like this. We could say custom min, and it'll be, can we do this? going to look like this: AB from val1 and can destructure this way, CD val2, and then we can say area 1 is A times B and area 2 C times D, and then we say we're going to return, say, if area 1 is less than area 2. So the way this is going to work is val1 is going to be the current reigning champ, and we'll say if area 1 is greater than area 2, and then return area 2. It's not really area 2 you're going to return. You're going to return, I think, val1, really. Otherwise, return val2. Or no. Well, do it this way. If area 1 is still the reigning champ, return val1. Otherwise, return val2. I think this is what we want for this function. It's going to be custom min, starting with these values. Now this is kind of involved, isn't it? This is kind of involved. Not quite what I was expecting when I said earlier, like, oh yeah, Clojure has sort of the similar sort of terseness of a scripting language. Not exactly. This actually ended up being kind of complicated, what I was trying to do here. Yeah, interesting. Print line of, what is this row column? Let's see what we get for each of these. It's a good thing the stream key is covered, because I'd be a bit concerned. Folks can see the stream. $65.13, huh? Which part of this is a problem? Main function eval. Boolean cannot be cast to a function. It might be this that's causing a problem. correct. What is this? Oh, interesting. So, I see. Huh. Actually, you can nest or put the destructuring right in here. You don't really need to do it this way. In fact, you can do this as well. Don't need to use a let. This is not smaller. Yeah. If they're equal, it doesn't really matter. And I guess I can make this an anonymous function, although it's kind of challenging. Boolean cannot be cast to function. Maybe we can print XF. What does this give us, after all? Is this a function? I guess this is the thing that's a Boolean, it's not a function. Not really sure exactly what the problem is. I don't know, transducers are kind of funky. I don't really know how to see what it does, what it is, how it's been defined. I don't think it's a Boolean though, which is kind of good. Wrong number of arguments. So how many arguments would you pass to this thing? Like what if you gave it this? Excuse me. Excuse me. think maybe I shouldn't be using this. That could be the part of the problem here. I'm not really sure why this is wrong. Boolean cannot be cast to a function. Where is it? Why? What is that? What is happening? I do not understand. I do not understand. Oh, I think I know what the problem is. Ah, I see. No, transduce has an initial value. This is the function, this is the initial value, this is the collection, and so if we did this, reduce custom min of the rest of this here. Oops. Actually, that should print everything. Yeah. 88, 99, 10, 10, 7, 7. Now, that works fine. But the issue seems to be when you apply this reducer here. It doesn't want to do that. So what happens if you can we apply XF to custom in, and then can we try to do So this is what it says. I'm a little confused by this, but let's see how this goes. So this does give you something, filter object, but we're not able to apply this in a reduction. Really interesting. Why is that? Oh, because this is a true or false. Oh, that's why. We can't filter and then return. I guess it's why. It's because this returns booleans. This is a function. I mean, this is supposed to be a predicate. I thought filter. Interesting. Interesting. So filter is supposed to return a sequence, right? Predicate must be free of side effects. Returns a transducer when no collection is provided. So it should be a transducer. This predicate. So this is supposed to be a transducer. I guess it's just not a transducer. What if we transduce on something else? I don't know, we can use a for xy of range. This will be range 10, or let's do 3, and y is range 3. Should create a vector. Yeah, con should be fine. Conjugate this. What if we say, instead of xf, we could say, we just say, you know, filter even, or, see, that's kind of the thing, it's like, you could take a single argument, but it's got to have a special predicate, no? Like, if we just said, let's do this. If we just said x, or just range, just outright range 3, right? Range 3, conjugate, filter, and we'll say even. Alright. Try that. That'll compile and print, I'm fairly certain. Right, no problem. Okay. Now if we use a anonymous function, we say let, say x, this argument, and we're going to say return, let's say x is greater than 1. Returns true or false. That filter. What do we get? Let's do 4 also. So probably see a 3 in there. Let's try that out now. Huh. Wait a minute, what? And this predicate is not... What is going on, man? Super confused. So we can use anonymous functions. What? But, oh, I don't think it's a true or false if you use an anonymous function. Oh, that's interesting. Oh, I see. It's actually not an anonymous function. Say if x is greater than 1, return x. Oh, I think that's the problem. This filter is supposed to return something, this predicate. Oh, no. What? Oh. Oh no, that's my mistake. Please. No pointer exception. Okay. How? But what? How do we filter? What does even do? What does this do? Oh. What? No, but this is. This. No. What? That's not a. This is not. No. Incorrect. This is. I don't understand. No, this is literally a predicate. This is true or false. This is true or false. I do not understand. Why does this not work properly? What do you mean? You know, there is something funky that goes on with these compilers. I've had this issue with HackerRank in the past, where it may have nothing to do with what I'm doing wrong. It could actually have just be that this is not even the. Oh man, I have to end the stream again. This is not even the interesting part. This is actually supposed to be kind of easy. This is a pretty minor thing we're trying to do. It's just I'm not familiar with transduce. And it also could be the compiler itself for HackerRank, the Clojure compiler. Like this might be completely valid Clojure code. It's just not working for whatever reason. For reasons that are beyond me. Like let's try this somewhere else. This code. Let's print this bad boy. Time limit exceeded. Serious. Gosh. And I betcha if we put this predicate in here, we just call it filter even, we'd be fine. You've got to be kidding me. What about an anonymous function that gives you even? 2. Also mod, I don't know that off the top of my head. So mod works as we expect. If I write an anonymous function, oh, you've got to be kidding me. You've got to be kidding me. Are you telling me that the only issue is the let in there? I think that's the problem. I think that it just doesn't know what to do with let. Yeah, it might be the issue. I think right. If you start with let and then use x. I don't think you need to use let. I'm thinking about it. So maybe that's the problem, is I just have the syntax wrong for the anonymous functions. Do not do this. Interesting. Can we destructure an anonymous function? I know what to do. Don't use let. Don't use the syntax either. Just use function. And it's going to be like this. Alright, I need to go. It's time for bed. X. Oh, I see. So you can do this. Instead of using let, just do this. Aha. Aha. I think that's what I'm doing wrong. Nice. Okay, interesting. So I shouldn't be using let here. I should just be doing right. I think I see the problem. I think I see the problem after all. It took a while, but had more to do with my knowledge of anonymous functions. So we use use a function instead of a let. And it's going to be, this is going to be an xy, single argument, and there's a pair of values, xy. And we're going to say if true, if and only if x times y is greater than or equal to L. Our anonymous function, use that filter. And that can then be used in our transduce function, and then we can sleep at night. It will be okay. Oh my goodness. Wrong number of args passed to. No. No. Oh, does it not work like that? Really? 2 args maybe? Could do it that way. Function 139. Can we just do this thing? We'll just say there's this. Please? Please. Destructuring that happens. Oh, custom min. Oh. Interesting. What? What? Oh! My soul. My soul. It's killing me, man. Yeah. This is killing me. This is killing me. Hey-ya. 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 Oh, it says hello. Okay. It's fine. It's okay. It's okay. Alright. If you transduce with this filter, and we conj over this thing, right? What do we expect to see here? Oh boy. Oh wow, compiles. Neato. Neat. Cool. Wow. Wow. Oh, okay. Well, there you go. So this actually works perfectly. This is fine. That's very interesting. That's not a problem at all. It's XF. Not an issue at all. Use the same filter, right? You could use just XF. Same deal. Oh, Yeah, you can. So conj works fine, but this custom min does not work fine at all. Hmm. 0, 0 in there, right? Try that now. Now, I don't know what to expect. I don't know what to expect. Yep, that don't make no sense. That don't make no sense. Oh man, I think it's gonna take me a lot of practice to get used to these transducers, custom anonymous functions and all of that, reducers and transducers and whatnot, combining these things. I don't know what is going on here. Arity exception, wrong number of arguments passed to row column custom min. What? You what? You what? Hurt your what? You hurt your what? You can do like destructuring right in here, right? I think this is what this means. That's fine, right? You could do 2. An arity of 1 though. If you only have one thing passed in at a time. I don't really understand that. Don't you have the initial value that's passed in? Like we could do reduce without a problem, I believe. I believe we could reduce without a problem. I need to go. Need to get up out of here. Yeah, reduce is fine. Reduce is no issue, but as soon as we apply this filter on top, suddenly it's a problem. And I, for the life of me, cannot understand. I, for the life of me, cannot understand. X 1, 2, 3, 4. Yeah, we have 4. 1, 2, 3, 4. 1, 2, 3, 4. I cannot understand. No, sir. Don't make no sense to me. Transformation of fx of f in it is not supplied. F will be called to produce it. F should be a reducing step function that accepts both 1 and 2 arguments. Oh, if it accepts only 2, you can add the arity 1 with completing. Oh, I see. Turns result of applying the transform of xf in it and the first item in the column. Completing. Clojure completing meaning. So it's good to read the docs. Some processes will not end, but for those that do, like transduce, the completion arity is used to produce final value in a flush state. This arity must call the RF completion arity exactly once. Inner function following shape. So we can create custom transducers. Core sequence functions. Let's read. Let's actually read this. I think maybe that's what I'm missing. I didn't fully read the docs. So you have an RF reducing function that it takes, and then it returns a function which has some steps, which is whatever that is, some result and some inputs. There's 0 arities, 2 arities, and 1 arity. Okay. So many of the core sequence functions like map, filter, etc. So these are overloads, I think. Take operation specific arguments, a predicate, function, count, etc. Operation specific arguments. Core sequence function, return a transducer of this shape, closing over those arguments. In some cases like cat, the core function is a transducer function. Does not take an RF. Okay. The inner function is defined with 3 arities used for different purposes. Init arity should call the init arity on the nested transform producing function, which will eventually call out to the transducing process. Oh, that's interesting. This will call the RF init function. Standard function is expected to call the RF step arity 0 more times as appropriate in the transducer. Filter will choose based on the predicate whether to call RF or not. Map will always call it exactly once. Cat may call it many times depending on the inputs. Interesting. So sometimes we'll call the init step. Interesting. So this transducer may call the reducing function. Filter will choose whether to call the reducing function or not. Oh, interesting. Map will always call it exactly once. Cat may call it many times depending on the inputs. Completion. Some processes will not end, but for those that do, like transduce, completion arity is used to produce a final value and or flush state. This arity must call the RF completion arity exactly once. Oh, interesting. So it's just the last, just calls it one more time with the last value of the completion, which won't actually do anything. So for our transducer, we need to just add this completion arity, which is x of f is the transducer, which is filter with a predicate. This function, the RF, wait a minute, why would, actually doesn't really make a lot of sense because oh, the RF needs a completion arity. I think that's what's missing. The reducing function needs one. Okay, that's fine. That's okay. Define a function. Just don't enclose it. Yeah, that's all. Just add another one of these. You say AB, and you return AB. That's it. I think that'll work. Is that the problem? No. Come on, man. Doesn't have an overload. Oh, come on. Oh, okay. You gotta enclose these functions. Alright. That's fine. Suppose. Something like this, maybe. Hey, it compiles. Holy guacamole. Jeez. Oh boy, we'll have to come back to this, I guess. Jeez, man. That didn't take forever. You know, everything's fine. It's just what I wanted. You know, it's perfect. That is wild. Well, we're learning about transducers and arities and reducers and all that fun stuff. That's what happens when you don't fully read the documents, man. The docs. 8, 8, 10, 10, 10, 10, 7, 8, 8, 8. 1, 2, 3, 4, 5. So 8, 8, 10, 10, 10, 10 we expect, and then write 7, 8, and then 8, 8. And you go to 7, 7 as well. If you put 50 in here. Or, no, 50 will be 7, 8. It's got to be 49 to get 7, 7. Yeah. Interesting question is figuring out all the points where all of those cutoff points where L x times x plus 1 is greater than L. Yeah. Where it's no longer greater. Certain cutoff points. It's kind of an interesting problem. But anyway, so wow, that was freaking wild, man. That took a lot of extra effort here. I wasn't expecting this to be so involved. But yeah, I guess when you're using a transducer, the reducing function needs to have multiple arities defined, or else. So yeah, maybe not as simple as I thought it would be. I mean, kind of interesting. You know, once you get the hang of it, and you get the idea. It's not too bad, but it's kind of relatively verbose for what I'm trying to do there, which is just filter on things that have a lesser area, and then also minimize based on the area. Sort of like minimizing with a custom comparator. Probably could have just applied the filter first and then reduced afterwards, and not need this extra arity in there. So what I would do is, instead of defining as the alternative here, let me show you what that would look like. You can just filter on this initially. So you apply the filter here, then you transduce, and instead of transduce, you reduce. This custom min of this here. Let me just put this back. and then comment this out, and then comment out the transducer, and try that one out, see what that looks like. That's a little more intuitive, and right, doesn't require this extra arity in there. Yeah, there we go. Oh boy, that's funny. I think I'll leave this though, as it was. It's just much fewer lines of code, I think, because having this extra arity just makes things confusing. And this actually could be an anonymous function, but you don't really want to stuff that in here. And this could be what you could do. What about this? I think that's better. And now we can say YY. That's a bit better. Fit it all in one line, like so. Yeah, that's pretty clean. It's relatively clean. Just thinking about how I can reduce the number of lines that we're working with here. Yeah, that's good. That is good. So we can comment out, we can remove these lines. It's still kind of like a lot of lines for something so simple, but yeah, it's good. It's not bad. There's a reduction. Just a couple filters. Cool. Cool. All right, let me get going. So thank you all for watching. And oh man, looks like tomorrow we're gonna have to revisit this problem. Didn't even get to the interesting parts. That was just like a simple calculation. Yeah, maybe this is better. Maybe it is better to use Python for these kinds of problems, or just generally use Python. I don't know. Unless you're really comfortable with I don't know. Maybe you just need some practice with Clojure. But it does seem kind of verbose. You know, this probably would be relatively simple in Python. Well, this is kind of simple. It's just that you needed to define these two functions to use them in the way that I wanted to use them. You can still define the anonymous functions too if you want to use let. It's easier this way. This one actually defined the function outright. I mean, I'm not sure how much less complicated this would be in Python. I think actually this would be equally complicated in Python. You probably write two auxiliary functions as well, and apply a filter, and then apply a reduction. It probably would be the same thing in Python. Actually, I'm thinking about it, because you're using a key function. That's what it is. It makes this kind of complicated. It doesn't really have a built-in min key type of function either. I think Python does, but this one not so much. Yeah, Clojure. But that's fine. I mean, it's only a few lines here. Technically, I could put this all in one line if I really wanted to make it quote-unquote less verbose. Actually, this whole thing could really be on one line. And remove the arity. And use the reduction instead of transduce. Transduce, it requires a second arity. Yeah, you could put all of this on one line, and then remove this line here, and then even put this on the same line up top. That would make things a lot simpler. It's kind of tempting. Think about doing that now. That would make things a lot cleaner, wouldn't it? It would. Let's try that. What that would look like. A lot less readable, I think. But very terse. And then, yeah, it's all just white space anyway. You end up removing this line. And so you'd have these two lines. And this custom min function. And this reducer with this filter in there. Yeah, I guess Clojure is kind of terse then if you do it this way. Kind of fast, kind of terse. Yeah, it's kind of cool. It's neat. Yeah, I take it back then. What I was saying about Clojure being maybe not as sort of fast and terse as a scripting language like Python. No, I take that back. I think this is sort of similarly like relatively quick to write with things up. This was supposed to take me like a minute or two, but I'm so unfamiliar and uncomfortable with Clojure and its syntax. That took me quite some time. I'm also still kind of getting a feel for like what would the appropriate sort of like when you actually write these things out, what would the appropriate sort of format look like? I think it's not too bad to put things on one line like this. This is not too bad. It's custom min function. You can kind of parse it relatively easily if, you know, this area is smaller than that area, then return the first or the second. I think it's not too bad. This is also similarly not too bad. You have custom min, you start with YY, which is defined up here. Filter on with this special function first before you apply the reduction, and this filter just goes right on these values, and this filter is a simple check that the area is greater than or equal to L, and that's it. Yeah, and you can remove all these lines, all this and all this, and even make this a little bit tighter as well if you really want to. Although I kind of like this kind of spaced out a bit after the let. I think it's clear, the things that you've defined. Putting two things on one line is kind of bad, but I kind of like it if they're just in this instance. So as we're trying to make things more compact. But for readability, you probably should just put it like so. Yeah, kind of neat. Kind of neat. Alright, so I should get going. Thanks again for watching, and yeah, man, learning Clojure syntax and arity and some good stuff, some fun stuff. Tomorrow I think I'll finish the problem. That was just one little piece. That was, like I said, it's supposed to take like a minute or two, not even a few seconds, just to code that little piece up. Sort of just a helper function to figure out what the row and column should be in a kind of a more you know, general way, I guess. Not even general, well, somewhat general. I mean, obviously these values, it's very specific how many values we've got. And then once we've got that set up, then the next step is to find a function that'll sort of do a conversion. Consider this sort of well, then we got to convert this string using a like a split, but more like a remove all the white space split type of thing. I'm not sure exactly what I want to use. And then we can interpret that string as a one-dimensional array, and interpret that array as a two-dimensional matrix. and then we can use this row column pair that we've got to properly access, and then we can write a routine that'll get the columns, each column, and then we can what do they call that? Join all of the column strings with the space in between. Yeah, in Python this is like very quick thing to code up. I think I have an idea how I would do it in Python, but in Clojure it's a little bit shaky. It's going to take me some time just to get familiar with all this. But once I get going, it should be much faster. Probably want to do about 10 of these problems. Probably not just 1 or 2 or 3 or 4. Probably like a solid 10 such problems, and then I should be a little more comfortable with Clojure. And then we'll go get on to the next thing after that. Just wanted to get my bearings, you know. I did read a lot of the theory about Clojure, and you know some theory and the core and some of the what do they call that, the example code, but all of that I was just kind of reading in my head. I didn't really get to messing around with it, get tinkering with it, get a better idea of what it is that I don't understand and the parts that I'm missing. So now I know. So anyway, yeah, like I said, thank you for watching, and talk to you soon. Have a good night.